In this video, we will be discussing about momentum, a key topic in AP Physics 1. Momentum is a vector quantity that is a product of mass and velocity of an object or particle. It measures how difficult it is to change an object's velocity and could be calculated through the formula P equals mv. In this formula, P is momentum, m is mass, and v is velocity. The unit for momentum can be written in two ways: kilograms times velocity or Newton times seconds. Impulse, on the other hand, is also a vector quantity defined as the product of force acting on a body and the time interval during which the force is exerted. Therefore, impulse measures the change in momentum using the formula joules equals force multiplied by the change of time.
Airbags are able to reduce the risk of injury in the event of a car crash because they're able to slow down the time of impact during a car crash. And therefore, by increasing this time of contact, airbags provide an impulse that reduces possible injury from car crashes. The conservation of momentum applies only to isolated systems. An isolated system is not acted upon by a force external to the system. This relates to Newton's third law of motion. For every action, there's an equal and opposite reaction. With two colliding objects, they experience an opposite force caused by the other colliding object. Therefore, the impulse experienced by the object is equal in magnitude, however, opposite in direction. And since impulse is equivalent to the change of momentum, the change of momentum of objects colliding are equal in magnitude but opposite in direction. Therefore, the sum of the change of momentum would be equal to 0, proving the momentum conservation theorem. Let's discuss what occurs in a collision with an object deemed as immovable or extremely heavy. If we have two balls, one ball bounces off the brick wall and the other ball stays stuck on the brick wall. For the ball that bounces off the wall, it will approach the wall at a velocity of v and then bounce off it at a velocity of negative v. Therefore, the momentum of the ball changed to mv in the situation since the velocity went from positive to negative. The ball that bounces off the wall and would experience the greatest impulse in the scenario since the ball was able to bounce back.
Total energy is always conserved in an isolated system. However, when discussing collisions, some energy appears to have disappeared. This is because some energy is converted into heat, sound, or other types of energy. These are the types of collisions. Momentum is conserved in all collisions, but kinetic energy is not. Different collisions are characterized by how they behave after the collision has occurred. In an elastic collision, kinetic energy is conserved. In an inelastic collision, some kinetic energy is lost. In a perfectly inelastic collision, the objects that collided will stick together and have the same velocity after the collision.
In this example, when a fly collides with the windshield of a truck, the fly sticks to the windshield and continues to move at the same speed as the truck. This is an example of a perfectly inelastic collision because the two objects, in this case, the truck and the fly, stick together once they collide and move at the same speed as if acting as one object. The first type of collision is an elastic collision. In this type of collision, two objects recede at the same speed they approach each other before they collide. As a result, there is no net loss in kinetic energy in the system. Both momentum and kinetic energy are conserved in an elastic collision. The total kinetic energy of two objects before the collision is equal to the total kinetic energy of the two objects after the collision.
The next two types of collision don't have energy conservation. The first one is inelastic collision. It does not conserve energy and changes into another form of energy instead. However, the total momentum is the same before and after the collision. In this collision, the objects recede at a slower speed than which they approached. The last type of collision is perfectly inelastic collision. Here, the energy is also not conserved, but momentum is. The maximum amount of kinetic energy is lost here when the two objects bond, creating the most extreme case of an inelastic collision. In this type of collision, the first and second objects stick to one another and continue to move at the same pace. An example could be a tackle in American football.